Hello folks, so in this video I want to just work one more example of creating an inverse for some function, and particularly of interest in this case is the domain and range of the inverse in this function. So this function, in case you're not familiar, is a rational function. It just means that the top and the bottom are polynomials. You may or may not have seen a lot of these in Algebra 2. So this is the graph of this function, and the reason I'm bringing up the graph is because I don't want to take too much time in terms of figuring out whether this thing is one-to-one or not. We can see from the graph here that this thing actually does pass our horizontal line test to check one-to-oneness. And so this thing actually is indeed one-to-one, so we don't need to worry about restricting the domain. So, well, what is the domain? So the domain of this function is, I'll do that in black just to keep color code everything. The domain of this function is, well, the only thing that could possibly go wrong here, because we have a fraction, is that we could divide by 0 potentially. And so the question is, well, when does 2x plus 3 equal 0? And that's going to happen when x is negative 3/2. So we have our domain is any real number other than negative 3/2. And that's where you can see, I guess it's a little hard to see on this graph, but this vertical asymptote happens at negative 3/2. Okay, what is the range of this function? Well, you can see here that it looks like it's going to hit any y value except for this one right here. The question is, where is that? And I'm actually going to ignore that question for now. Okay, so let's go through our steps here. So we've determined that's already 1-for-1, and let's figure out what the inverse is. So to find f inverse of x, well, again, I'm going to exchange x and y. So our new function is going to say x is equal to 5y minus 8 over 2y plus 3. Okay, so now we just need to rewrite this equation so it's y equals. This part's a little tricky, but it's doable. Okay, so let's get all the y's kind of on one level. So what I mean by that is we'll get all the y's in the numerator. So I'll multiply both sides by 2y plus 3. When I do that, I'll have 2xy plus 3x equals 5y minus 8. Okay, so you can see here I just multiplied both sides by 2y plus 3 and I distributed that x. Well, I need to get all the y's on one side at some point, so I'm going to put the 5y on the left side, and I'm going to put the 3x on the right side. So I'll get 2xy minus 5y equal to negative 3x minus 8 at that point. Now we can see that you can actually factor out the y's on the left. So we'll have y times 2x minus 5 is equal to negative 3x minus 8. And finally, we'll have y, which is really f inverse of x, is equal to negative 3x over minus 8 divided by 2x minus 5. Okay? Check this out. And then we could graph in if we wanted to by just simply drawing the mirror image of this across the line y equals x. But that's not quite what I care about in this particular instant, or at this moment. My question is, what's the domain and range of this function? So the question is, what's the domain and what's the range? Well, here's the thing. If I knew the range of the original function, I could find the domain of the inverse. Unfortunately, I didn't figure out what the original range was. Similarly, well, we do know that the original domain is all real numbers except for x equals negative 3/2. So that's actually tells us what our range is. Our range on this function is that y cannot equal, or I guess not y, but f inverse of x, which is y, but why not use our notation? Will be anything other than negative 3/2. So if I don't know the original range, though, how do I get the new domain? Well, folks, remember that this function that we just came up with is still a function like we know, and so the same rules apply. What could potentially go wrong in this blue function? You might divide by 0. What's going to cause you to divide by 0 Well, let's just double check here. 2x minus 5 equals 0. 2x equals 5, and so x is going to equal 5 halves. So if you plug in x equals 5 halves to the inverse, you're going to end up dividing by 0. You're going to have an undefined function. And so that value is not in the domain. Sorry, not negative, just positive 5 halves. And likewise, we can use that to now find out what the range of the original was. And so we can see that the range of the original is simply all y values that are not 5 halves. Okay. Now I don't want to get too far into where this comes out with rational functions, and I'm going to be doing that for my Algebra 2 class anyway, so I might link that video in case you're curious. But there is a way to figure out in the original function here that y equals 5 halves is not going to work out. But if you're curious about that and can't wait, shoot me an email or drop by office hours. Okay? So thanks for watching, and I hope this helped. See you around, folks. Stay spicy.